Vanakkam, now we are going to solve problem 3.6 from Digital Design by Moris Mano's 5th edition. The question is to simplify the following Boolean expressions using 4 variable maps. So here we are going to use K map, but already we have solved the problems A, C and D. So now it is time to solve B problem alone. So the problem is x dash z plus w dash x y dash plus w into x dash y plus w into x y dash. This is the problem given. Okay, so min terms are not directly given, only this product terms are given. So using this we can place directly the ones into the cells. So you can place a 1 here corresponding to this x dash is it. So x dash, so here in this x dashes are available and z's are available here. So you can place ones here. Then for the second one, second term is w dash x y dash. So for that w dash x, so this corresponds to w dash x, and then y dash, so y dash is on here, so you have to place ones here. Then we go for the third and the fourth terms. They corresponds to what? Actually w x dash y, this is your third term, and plus the fourth term is w x y dash. So this is your fourth term. By using distributive law you can multiply these two and get this third and the fourth term. Okay, so for this w x dash y, so it corresponds to here, y corresponds to these two, right? Now you can place ones into this already because this is covered already. Okay, then you go for the fourth term, it is wx y dash. So wx is here, y dash is on these two, so you can place ones here. So now it's time to group them or combine the number of maximum possible number of adjacent ones, which can be written in powers of 2. So we don't have all the 16 cells covered, so now we look for 8 number of ones. We don't have 8 number of ones, so we go for 4 number of ones. So in this case, if you look at, we can form the 4 ones covered like this. This can be taken as loop 1. Then you go for second loop formation. There it is by combining these 4 ones, so it can be named as loop 2. Then you can go for forming loop 3. So you can combine these min terms. So this can be termed as, this can be named as loop 3. Then you can go for loop 4. Loop 4. So by combining these two ones, right? So this is our loop 4. So now we can write the expression corresponding to this loop 1, 2, 3 and 4. So for loop 1, if you consider all these rows are covered, so here you get a 1. Column wise it covers this one, so y dash is it alone. Then loop 2, it covers row wise w dash x and w x. So here these two get cancelled, x is redundant, so you get only x here. And column wise it covers y dash z dash y dash z. So y dash is redundant, z dash and z are complement, so you will get only y dash. So this is for loop 2. Then loop 3 covers here row wise and column wise these two, right? So it is w dash and w get cancelled and x dash comes for twice, so you can write x dash once. And here it is y dash and y are covered, they are complement, y dash and y are complement, so you can cancel out, and this is it comes twice, so one is it is enough. Now we go for loop 4. So loop 4 it covers this row wise, column wise these two, right? So it is w x dash, here y comes because these two are complement and this is redundant. So all these product terms can be written as prime implicants. This is pi1, this is pi2, this is pi3 and this is pi4. But if you look at these loops, this prime implicant one, if you take, this corresponds to this yellow color, right? So this particular cell is covered twice by yellow color as well as this red color, right? And these two cells covered by blue and yellow, and this is covered by yellow and this red. So all these ones are covered by two loops. So this is not essential prime implicant. This is not an essential prime implicant. So you are not supposed to include this in your simplification. Okay, in your simplified answer, this is not supposed to be included. And when you go for the second loop 2, here these two loops, these two ones are covered by two loops, that is yellow and this blue, but these two ones are not covered twice. It is covered, they are covered only once by this blue loop alone. So this is coming under this essential prime implicant. Okay, this is our essential prime implicant 1. And then you go for the third loop. So in this third loop, these two ones and then these two ones, this orange color, right? So this one is covered once. Other things here it is covered twice. This one is covered twice, and this one is also covered twice. But this is covered once. That's why this is also required. So this is also essential. This is our essential prime implicant number 2. Then you go for this last loop. In this last loop, we have these two ones, right, are covered by this green color. So in this midterm, or this one is covered twice, but this midterm is covered only once. Okay, only green color, but here you have red and green, right? Anyhow, a minimum number of midterm is covered only once. That's why this is also essential prime implicant. So it is EPI 3. So using this essential prime implicant only, you have to write the simplified expression. So now we get the F simplified is equal to, this is, should not be written, right? So we have to start writing from here. That is x y dash plus, this is x dash z plus, this comes w x dash y. Okay, so this is the answer. So how many essential prime implicants are there? So we have 3 essential prime implicants. And how many prime implicants? 4 prime implicants. Okay. Thank you. Hope you have understood.